Instruction formatting and mnemonics. Consider a simple CPU which has just one general-purpose 16-bit register, called the accumulator. This accumulator holds the data being operated upon. All data is stored in the accumulator, including operands and results from arithmetic and logical functions. Because there is only one general-purpose register in the CPU, instructions will know to refer to the accumulator, and therefore we do not need to specify the accumulator as one of the operands of an instruction. Thus, instructions which perform addition, for example, only need to supply one operand, the value which is to be added to the accumulator. For example, add 5, would add 5 to the value within the accumulator and store the result back into it, overwriting the previously stored value. Our example instruction format will be made up of 6 bits for the opcode, giving 64 possible operations, 2 bits for the mode field, giving 4 possible addressing modes, and an optional 16-bit, 2-byte, operand. Note that the opcode and the mode field make up 8 bits, and can be conveniently stored in 1 byte, that is one memory location. The diagram shows a number of common opcodes that can be used by most CPUs. See how some opcodes require an operand, while others do not. For example, opcode 000101 requires an operand, as this opcode is used to load data into the accumulator. Without the operand, the memory unit would not know which address to get the data from. On the other hand, opcode 000011 performs a NOT function, which simply toggles its bit in the accumulator, making a 1 a 0 and a 0 a 1. This does not require any further data, or operand, from memory, and can execute immediately. Entering opcodes to create a computer program can be both time-consuming and prone to human error. With the introduction of assembly programming, the opcodes were replaced with mnemonics, short abbreviated words that were much easier to remember and understand by humans. The assembler program would then simply convert these mnemonics back to opcodes, before executing the program on the computer. Addressing modes are used to indicate whether the value being given as an operand is the actual value, or the memory address, where the value can be found. Here we can see how an addressing mode of 00 represents no operand, and this would commonly be used with opcodes such as shift left, where no operand is required. Addressing mode 01 indicates that the value being given as an operand is in fact the actual value. On the other hand, mode 10 would indicate that the value is a memory address, and the CPU would need to fetch this data from the memory unit at the location specified by this address. Address mode 11 is not used. Note that one convention of specifying whether the operand is a value, not a memory address, is by suffixing the mnemonic with a hash. Hence, add #5 would simply add 5 to the accumulator, while add 5 would add the number found in address location 5. These conventions are dictated by the assembler, not the CPU. Meaning one assembler program could be used to run assembly code on multiple CPUs. Thank you for watching.